on yesterday. Okay, so please, if you didn't introduce yourself to us yesterday, please kindly introduce yourself to us today. Tell us your name, where you are joining us from. I can see Clementina Motunayo. Thank you very much for joining us. I didn't see you in yesterday's class, but we are glad to have you here with us today. So without further ado, we'll be starting the class shortly. So please let us turn off our microphone so that we'll be able to have a clear conversation with one another. So please just notify me if you can see my screen. Okay, so can you see my screen?
Yes.
Okay, thank you very much. So we'll be starting the class right about now.
Good evening, everyone. Good evening. Okay. Has it been a stressful day from your ends? Because I can see that many of us are not responding as we supposed to. Okay, so yesterday we started the. Can you hear me and can you see my screen?
Yes, we can hear you and we can see your screen.
See my screen? Just give me thumbs up. Okay. Okay, I see. I see. All right, thank you very much. So yesterday we started the course, industrial machinery maintenance, and we dived into maintenance as being, activities that we carry out on machines in order to put them in a good shape. So I explained why we need to, perform maintenance for the sake of reliability of our machines, and that these machines, they should be treated exactly as we also have, senses of organs, that, your sensors on your machine, they have what they are communicating to you. When the temperature is high, it has something that what is communicating to you about your machine. And by putting maintenance into our culture across every industry can actually elongate the lifespan of the machine, can secure our own safety as personnel that is working on the machine. It can also give us a good reliability so that the production of the company also will not be affected. So yesterday also we discussed that what it costs, to perform maintenance is very negligible, or let me say, it's just a percentage of, what it may cost you. So in other words, it pays for us to maintain machine than for them to actually what fail. Okay, because when they fail, that you may not guarantee, depending on the or on what caused the failure, you may not guarantee the uptime. So the downtime, might actually what linger than you expected. But when we perform necessary maintenance on the machine, it's guarantee what reliability. So I ended yesterday's class with, we discussed a whole lot. Yeah, that yesterday, but I'm just trying to like give you. I still appreciate our moderator. I think he dropped the recording of yesterday's class. So I promised you yesterday that we would look into MTBF, that's mean time between failures, mean time to repair, okay, and also I discussed one yesterday, mean time to failure. So let me share the screen from this, my other device. And then we'll look into this calculation very briefly. I think I still have the page. Okay. So we'll look into this calculation together. So I really want you to please give me your undivided attention in order to really get this calculation once and for all. So I'm going to be using some illustration. I explained yesterday, some people will say they will call this mean time. You can see it as mean time between failure or before failure. Okay, so I choose to call it mean time before failure. So let's first deal with what mean time, okay, before failure. Okay, mean time before failure. So let's say we have a machine, okay, that runs for, they run this machine, the uptime of this machine is actually 10 hours. So I'm going to write that uptime equals to 10 hours. So the company actually proposed to run this machine for 10 hours. Okay. And let's say within that 10 hours, we have some failure that occur. Let's say failure. And let's say this is downtime. So the first failure occur, and we have another failure that also occur here. So this failure that occur here lasted for 2 hours. That's the downtime. And the failure that happens here lasted for what? 1 hour. So from this, we can easily see that our total operation time. So total operation time will definitely be that. Yes, our uptime, or let me say our proposed production time, okay? Let's use that so that it will not mislead us. Our operation time. So this is the operation time. The company actually wants to run this. They need this machine to run for 10 hours, okay? But right now they have about 2 downtime, which is 2 failure, okay? And this 2 failure actually one lasted for 2 hours, the other one lasted for 1 hour. So our total operation time, which is TOT, will definitely be our operation time that we actually propose to run the machine minus the downtime. So this is no calculation. What we're actually discussing is that there is a company that they have a machine, and this machine is actually scheduled for an operation, for a 10 hours operation. So this is when they need the machine. They need it to run for 10 hours. But during these 10 hours, it happened that there are 2 failures. Okay? There are 2 failures that actually occur during this particular time that the machine is supposed to operate. And one of them lasted for 2 hours. That's look. Yeah, it's coming. Yeah. Please pardon me. Sorry. Pardon me. Sorry. So this failure, the first failure lasted for 2 hours. The second failure actually lasted for 1 hour. So if you want to look at how many hours, that total operation time, total availability time that the machine has operated now, will be the 10 hours that we needed the machine minus the total downtime, which is 2 plus 1. That's 10 minus this. That gives us what? 7 hours. Now, 7 hours, the machine has actually what? Successfully run for what? 7 hours. Now, we want to know the mean time before failure. Don't forget, anytime we are talking about mean, we are talking about average. So what is the average time that the machine actually run before it fails? That's the interpretation of mean time before failure. Let me take that interpretation again. What is the average time that the machine actually what? Run before it fails? What is the average time that this machine run before it fails? That will be the total operation time, which is TOT, divided by number of failure that is recorded. And if you are going by this calculation now, that will be 7 hours, which is what? Total operation time, divided by number of failure. How many failure do we have here? 1, 2. Just 2 failure. And that will give us 3.5 hours. What does that mean? By this calculation, this is how company actually what? Predicts, the reliability, or this is how they actually calculate the reliability of every machine. Every manufacturer also do this. And sometimes when you are talking about industrial machine, we care so much about MTBF. But if you are talking about maybe consumers goods or consumers machines, most of our domestic machines, most of us don't really look at what MTBF. We don't really care. Because we don't need them to run for a long time, okay? Or we are just looking at what the low cost of that particular machine. But every company wants to actually know for how long can this my machine sustain me. So you can imagine what is the interpretation of this now. It means that this machine will always fail at every 3.5 hours. Once this machine runs for 3.5 hours, it will fail. That's what MTBF that we have calculated actually means. So it means that the reliability of this machine is based on 3.5 hours. That is, this machine, when you power it on, when it runs for 3.5 hours, it will just go off. It will fail. So we are using hours to calculate this. So in case if the hours is now much and then we run it into this, that's when you see, the company will now say, okay, fine, we have known that this machine will fail for 3.5 hours. Don't forget yesterday, every 3.5 hours, this machine will go off. Then we go to preventive maintenance. So on this machine now, we explained yesterday that preventive maintenance is a scheduled maintenance. So because we have known that this machine, every 3.5 hours, it will go off. And mind you, we needed this machine to run for 10 hours. In order for us, if you don't have a better machine to replace this machine with, we can now say that every 3 hours, the machine must be shut down for maintenance. So you see that. So that, we have already set the preventive maintenance schedule to be just before the time that the machine will fail. And that would make us to, if we are the one that shut down the machine on our own, perhaps we check what is making this machine to go off. Maybe we have already known that maybe the oil level always go below the normal. Then we top the oil, we clean, maybe there is dust that will have been covering a particular contact or anything, we clean it, and then we start our machine. Then we are sure that the machine will still run for another 3.5 hours. So before it runs for that 3.5 hours, in the next 3 hours again, we shut it down. In some company, you see some machines that their own is 3 days. Okay, they shut it down. I have people here that maybe you are in charge of some maintenance in your company, or you are familiar with some machines that they have. You are familiar with the time that they normally shut them down for maintenance. I would have loved those people to share their experience. So there are some machines that they shut down 3 hours, I mean 3 days, every 3 days, every 4 days. But how do they know that what this one should be shut down after 3 days? How would they know that this one should be shut down what after 7 days? That's because what there has been calculation on what MTBF, which is what mean time before failure. What is the average time that the machine will run before it fails? So every machine. So what happens when you see a machine with low MTBF? For example, if you see a machine that have what MTBF of 3 days, and you see a machine that have what MTBF of 7 days, which of them is what a better machine? So that's the question I'm asking. If a moderator is there, if the moderator is not there, no problem. Just raise your hand.
Yeah, I'm here with yours. I'm here with you.
Okay. Anybody that wants to answer that question? A machine with MTBF of 3 days and a machine of MTBF of 7 days. Which one is better and why?
Ezekiel Afan, are you there? I can see your hands. Ezekiel Afan. Ezekiel Afan, can you hear me? Okay, Fawaz,
Can you hear me? Ezekiel is up now.
Okay, Ezekiel, you can respond to the question.
Yes. Yeah. Mean time before failure of 7 days gives us a better availability compared to mean time before failure for 3 days. So it's a better machine. The second one is a better machine.
God bless you. So now we understand this now. Very, very confident that we understand this. So the one with MTBF of what 7 days, it means that what has a higher reliability.
Yes.
And this is how you can even choose which kind of, you can have what, maybe different manufacturers of a particular machine that is doing the same thing. So you have tested these products, with the MTBF, you have tested this product with the MTBF. So you know that what this will actually be much more reliable. We don't just say the machine is much more reliable by just looking at it. It is by putting it to test and calculating what the mean time was before we run it to failure. We see how well it can actually run. First, before we determine MTBF, we have to first run that machine and see what when will it shut down. We perform this is we see how long the first downtime, how long did it take us? The second downtime, how long did it take us? And then we use this to calculate our MTBF, and then we know the reliability. So that's about what MTBF of a machine. So let's talk about MTTR, which is mean time to repair. And I actually explained this yesterday a bit. I think I explained this one a bit. Let's say that, let me give us an illustration. Let's say we have a company that they run for their operation within a week is 40 hours. Okay. And they run for 40 hours. This is their TOT. Total operation time is 40 hours. And then within these 40 hours, they had 4 failures or 4 issues. Let me use the 4 issues. Don't let's call it failure. 4 incidents actually happened, which actually means what? Downtime or 4 downtime.
Hello, sir.
So this is their total operation time. That's for 1 week. They were off for 40 hours. Okay. And then they recorded 4 downtime. But the total time it takes them to resolve these 4 failures. That's 1, that's the first failure 1, failure 2, failure 3, failure 4. The total time it took them to resolve this failure is actually what? 1 hour. When
Yes, I have a question before you go further.
Said 4 failure. So how long did it take them to bring it up the first time, second time, third time, fourth time? So they had all the time together, and then they see that okay, it's actually 1 hour They use 1 hour to bring to resolve the 4 failures that they recorded. So how do we know our MTTR? That's mean time to repair. Don't forget mean. Mean, of course, we remember what mean is. If I say find the mean of 1, 2, 3, 4, 5. I hope all of us are familiar with that. We had everything together. Okay. And then we divide by the number of this number, which is what? 5 numbers. That's 5, and that will give us what? 3. Okay, that's what mean actually mean, and that's what we are doing. So we want to find the mean time it will take us to always what? Respond to failure, or to always bring up a machine that actually what? Fail. So if we are to do this, 1 hour is actually what? The time, and the number of failure recorded is actually what? 4. So we can convert this to a minute, which will give us 60 minutes divided by 4, and that will be what? 15 minutes. That means that what? Our MTTR is actually what? 15 minutes. So in other words, if we are going to what? Interpret this, MTTR let us know the responsiveness of our what? Of our maintenance team. How long does it normally take them to resolve a problem? When you want to get contracts from a particular company, like I've worked with a company before, I won't mention name. Many of us that have worked in telecommunication industry, we know that all these telecom industry like MTN, Glo, etc., they do not, before when they started, they normally employed the site engineers themselves. Those are the site engineers that manage all these, or that maintain all these their masts, all these their sites. So they used to employ them in those days. But later on, they wanted to do away with that load, that stress. So they started what? Giving contracts to some, maintenance company. That way, they can sign a contract of 5 years, 10 years. So they are going to be on maintenance of all their sites. And there's always what? Deal with them. That what are the allowable or the tolerance time for a particular site to actually what? Go down. What is the tolerance time? It is when this company actually will default with the tolerance time, definitely in their calculation of remitting the money to them is going to actually what? Affect that company. So the company I work for was a company that actually got these contracts. Okay, many of us may who have the idea of telecom will actually know what I'm talking about, because in every month you have the electronics guy and you have the power guy. There are some people that the engineer is just in charge of the power. So he's the one that you will be seeing that will be coming to site to check the diesel level, to maintain the diesel generator and all that. Those are the power guys. The electronics guy, they are the one that will be opening those, all those transmitters, checking them. If the programming has corrupted, they will delete the one that is there, upload a new one or update. So you see them bringing laptops to troubleshoot. If you have seen them around you, you will know what I'm actually talking about. So I actually worked in the power sector of it. So one of the things that they care so much about, that's where I'm going, is the MTTR. That is the responsiveness of your team. We don't say that there will not be downtime. Of course, downtime will always happen. Like we explained yesterday, maintenance are of different types. If it is not preventive, it can be corrective. And in most cases, it is not that you do not perform the preventive maintenance. In most cases, or let me say in few cases, there are few occurrences like that is not just because you did not do a good preventive maintenance, but something may happen that the machine will just fail, and you have to repair it. It might be a major failure. It might even be the part of it that you never even touched during the maintenance. So anything can happen that can make a machine to fail. Whether you perform a good preventive maintenance or not. We're just saying that what good preventive maintenance will always reduce the occurrences of such failure. If you perform the maintenance very well, yes, it's okay. We have people like I had a funny story of a man who, you know, cares so much about his health, and because of that, he normally take all these Ever water. I'm sorry to mention the product Ever water. We know that it's a very clean, you know, water. So it is not the Ever that is using, but I want us to pay attention to what I'm trying to bring out from there. So he was actually taking clean, you know, source of water that, of course, many of us know that if you go to hospital, if you want to use drugs and you carry Ever water that you want to use to take drugs, you are considered to be safe. It means that the water is very, very clean. But for this man, despite taking what, you know, clean water and all that, you can imagine somebody, if you want to eat, this is the water that he drinks and everything. It was not even, you know, tampering with sachet water. No matter how pure you think that it, or you advertise it to him. But he fell sick along the line and he went to hospital. And when they diagnosed him, they said that he had typhoid. The man was surprised. He told them, I take clean water. He said, you have typhoid. That's when he now began to have the orientation that typhoid does not really mean that what it does not have to do with water alone. What about the food that you eat? You can eat any contaminated fruit and all that. So the educated in that say, okay, so if I can actually contaminate, if I can be down with typhoid, despite the fact that I care so much about the kind of water that I drink, and from that day, there is no kind of water that you give this man that he would not drink. Bring pure water, bring anything. After all, he has taken clean one before. He said I should just be taking anyhow water now. If after all I'm not actually safe. So what am I saying in essence? You can do every preventive maintenance on your body. That doesn't mean that if you want to fall sick, that what you will still not fall sick. There might be anything that can trigger or sickness. And likewise on machine too, you can do all the preventive maintenance. It is still possible. The percentage may be very small, but yet a machine may still fail. So there will be need for us to have a good responsive team. And this is what qualifies you as a maintenance person. It is not just for you, it is not enough for you to know what to do, but for you to do what you have to do very fast and very quick, such that what you will be able to actually reduce the downtime. In those days that I work in such an industry, you will have a walkie-talkie attached to you if you are a maintenance guy. Even if you are in operation also, you have a walkie-talkie, and you will be communicating 24/7 what you are working on. What is the progress of what you are doing? When do you think that's the question they will be asking you? When do you think that this machine will be up? When I was working in that telecom industry, they will call you at night. Your support engineer, because I was the senior field engineer, my support engineer might be, because I briefed him about everything, I carried him along. He will be briefing them. They will say that no, they don't want to hear him. That he should go and wake me up. I must be the one to actually give that report. Because what everybody, all those, you know, superior to you, what they are after is that they want to reduce the downtime. Because that's where they lose money. In production industry, in manufacturing industry, every 1 minute, every 2 minutes, even every seconds that make up a minute can't. I don't want to mention him. The company where I work in Kogi State, some of us may connect from the training of yesterday. I think I mentioned him. They did calculation for us to know what the company will lose if a unit is actually shut down for 1 second. The money was not calculated in 1 hour. I want you to listen to me. They had to do the calculation of the millions of money that is lost if we are to record a downtime of 1 second. So you can imagine. There are many people that have been sacked in company due to downtime. So your responsiveness, MTTR has to do with the responsiveness of the maintenance team. How fast can you actually bring up a machine? Okay? And if the preventive maintenance is actually very, very good, trust me, it will be easy to bring up a machine. It will be very, very bad that when the machine actually fails, when they check it, they see that it is the oil level. It means that the maintenance guy have not done anything. But when the machine actually go down, it should be a major fault. It shouldn't be that what the oil level has gone down, there's no water maybe in the radiator, there is no this, all those normal things should actually be done, just like your car. You can do everything, take it for checkup and everything, and the car may still develop faults. But that shouldn't be because you did not do the maintenance. The maintenance has to be done, which is the preventive maintenance. So enough of that on limited to bring it up anytime it would fail. Our team brings it up within 15 minutes. It means that they understand the machine. It means that definitely perhaps they carry out a good preventive maintenance on this machine. If you poorly maintain this kind of machine, trust me, the MTTR may increase to 2 hours. Because by the time the fault happens, it will always be a major fault. When the temperature is high, the machine is supposed to shut down. The machine did not shut down. It continued to run and run and run. And by the time the machine actually was shut down, definitely the high temperature must have spoiled and damaged so many things inside the machine. And there will be a whole lot of work for you to actually bring it up. So that's MTTR. Let's take the third one, which is MTTF, mean time to failure. Mean time to failure. Mean time to failure. Okay, mean time to failure is normally used to calculate the lifespan of a machine. Okay, if you check your car, the speedometer of your car, it will be showing you, how many kilometers this how many kilometers has your car actually traveled ever since it has been commissioned as a car. So you'll be seeing it there. So we use these to know a better product. For example, this product is being made by this company, another product by this company, both of them are serving the same purpose. Let's use example of bulb. This is a bulb made by company A. This is bulb made by company B. We want to know which of them are we to buy that really have a longer lifetime. If we have to calculate their mean time to failure, then we'll be able to know a better one. And what do they do in this case? We are going to take the sample, 4 samples of A. If you want to get an accurate result, of course, you should use more than 4 samples. But we'll get 4 samples of A. And we power them up. Okay? Power the 4 bulbs, which are made by company A. Let's say this one blow out. This bulb actually blew out, after 10 hours. This one blew out after 8 hours. This one, let's say 9 hours or thereabouts. Okay. And let's say this one 3 hours. So we want to know the mean time to failure. So we then have 10 plus 8 plus 9 plus 3. Should we use 3 or let's just use 9 still? Okay, 9 divided by 4. So if you calculate this will give us 36 divided by 4, and then that will give us 9 hours. So it means that whenever we are purchasing this bulb, we have a level of confidence that the bulb will spend only 9 hours and then it's going to blow up. So the lifespan of this bulb is actually 9 hours. The mean time to failure of this bulb is actually 9 hours. Let's say we now see another bulb. By the time we calculate for bulb B, we calculate the MTTF of bulb B. We do the same thing, the same way we get the sample here, and this one now give us a 15 hours. What does that mean? If you have to buy, you know, as an engineer, if you have to buy any of these words of this bulb, which one will you go for? Is it the company A or company B? Anybody, just raise your hand. Let me see who is following us. Which one will you purchase? Is it the company A or company B? Anybody? Moderator, are you there? Mr. Moderator, are you there?
Yes, I am here. About Yama Afwan, you can unmute. I'll buy one of company B because the mean time to failure is 15 hours. Why the mean time for company A is 9 hours?
What does that mean?
So it means that the average time for B can fail is higher than the average time for B to fail. So I think I will have more time to use the for B than the time I used using box A.
Thank you so much. So this is how you see that, you know, you will see that why do they like this product? Is this product, it's not just by mistake. It's something that you can also try. These are experiments, okay, that people actually do. They intentionally find a study. If it is a bulb you are using, I'm just using a bulb for example, it might be a different kind of machine. You just want to know how long it will actually take before this machine actually pack up. So you see some companies that normally do new editions of their product, like they normally improve on their products. All these companies that make cars. So you say, oh, these Honda, so they will make another advanced one. These are the things that they actually improve on. So they want to improve on the lifespan. Sometimes they want to improve. They use the MTTF of the last version to actually create the new version. If the last version normally lasts for 20 hours, we want to ensure that our client would be able to enjoy the next one more than 20 hours. It might be 25 hours, so that they will find the new product better than the old products. So this is what actually govern maintenance, okay? The scheduling of maintenance across the industry. If you understand these that I've done, please give me a thumbs up. I really want to have your thumbs up if you understand everything I've discussed in this area. All right, thank you so much. Thank you. Let's switch to our, yes. Thank you so much. Thank you. That's great. Thank you. So we are moving on. So this is what we discussed, the extent to which we discuss. Yes, there are so many things for us to discuss. I've run through the types of maintenance. I've run through that. And yesterday also we discussed the benefit of effective record keeping already. So we discussed best practices for record keeping, where I was talking about CMMS. That is that it is a software that makes you to automatically schedule the maintenance, and you'll be able to actually attach the name of the personnel that would be in charge of that maintenance. So let's move on by now discussing a lubrication system. So briefly, I mentioned it yesterday, but we just want to elaborately look at what lubrication system of maintenance or in machinery actually entails, because it's part of the things that you touch when it comes to maintenance. The first thing you need to understand about lubrication system is that we use it to actually reduce frictions in machinery. And talking about friction, because I believe that we have a lot of people that are engineering oriented among us. So friction happens when a metallic surface, let me use a metallic surface because that's what is not, it doesn't necessarily not to be a metal, but because we are dealing with machines. So you can see when you take two metals and you rub them together, what will happen is that there will be restriction in their movement. So imagine you take two spoons in your kitchen. You are trying to to rub them on each other. Notice that effect. Now that same 2 spoons, get what? Even a palm oil, or you can get a groundnut oil, rub it around those 2 spoons. Now try to what? Rub them on each other again. What do you notice? So you can actually try that out. Try it out if you have not practically what? Seen the effect of friction before. So take 2 spoons, metallic spoons, rub them on each other, feel the movement, and now put oil around them. Try to rub them on each other and see the movement. You will see that when you apply the oil, they are going to move, much more freely on each other. And that is that's how to actually reduce friction. It is that restriction of movement that we call what? Friction. So when you apply lubricant, they reduces what? Friction. They also prevent what? Corrosion. So, okay. If you check, you see that we now use electrolysis to electroplating. How many of us may actually know what I mean? So it's part of the benefit of electrolysis, back then. So electroplating simply means that if you look at some of the spoons that we use now, in those days, I don't know many of us that made those kind of spoons. They were actually made of metal. You see them very heavy. Even before you put food in your spoon, the spoon itself is a load, is stress. Until we now begin to have all these stainless spoons that are actually being electroplated with silver. So they are coated with silver. So all these things, this coatation is to prevent corrosion. So also, if you put oil, you oil the metallic or rotating part of a machine very well. It helps them not to corrode. Okay. Lubricant also helps to remove heat. Many of us even practically do this. Okay, if you have a burnt, if you sustain a burnt at home, you may quickly get palm oil. You say you are dipping that place that is burnt, you want to put it in palm oil. Why? Because you believe that the palm oil can actually help you to extract heat of that burnt place. So exactly, so some of the lubricants are also for the purpose of removing heat from a machinery. Because excessive heat will always damage some part of the machine. So we want to apply lubricant to remove it. Some of these lubricants are also meant for cleansing. Okay, I explained this in the last class. They can remove a debris. Let's say you have some part that eventually, wears and tears and all that. This oil being in the system can really separate some dirt, okay, from such system and prevent further damages. Okay, and eventually applying the lubrication system, making the lubrication system to be intact will also help us to improve the efficiency of a machine. What is the efficiency? When you reduce friction, you are going to use a lesser energy. The energy consumption will be lower, because machine won't have to struggle to overcome friction, to overcome the opposition, to overcome the movement that is not smooth. The machine will not struggle to move. The rotating part will not struggle to rotate. So if there is no struggle for them to do all this, you will need a lesser energy to rotate them. And that will also kind of help your power. And you can see what power generation is actually talking right now. You can't really imagine what many production or manufacturing company who have to provide their own electricity. You don't know what they may actually be going through right now, especially in this part of the world. So if there's anything that you need to do, which is, you securing the lubrication system of a machine in order to actually use the lesser energy. Of course, why wouldn't you do that as an engineer? So let's move to the cooling system. Sometimes people also look at cooling system as lubrication system, but I've explained the lubricant, some lubricants also, they cool down the system. Why they cool down the system? By removing the heat. But we have to discuss the cooling system, differently, because cooling system is actually centered on, regulating the temperature of the mechanism. So we have to, you may have your fan, you may have a cooling fan, okay, that is actually extracting heat or blowing out heat from the machine, or blowing air compressed air on the, the part of the machine that may heat up. When you look at your electric motor, you can have what? Overheating. You can have a insulation failure if the fan, the cooling fan actually failed. So when there's overheating in a machine, if there's any part that is insulated, the insulation will break down. All those wires that are used to coat your coil inside your stator, your armature, everything will actually burn. And once you have one phase already touching the other phase, what will happen? There will be a problem. There will be we say there is a short circuit in the machine, and then the machine will have to shut down. So cooling system regulates the temperature, and of course, by regulating the temperature, it will prevent damage, because high temperature or excessive temperature will actually damage the part of the machine. And this will also improve the performance of the machine, because when the machine is not is not overheated, of course there is no way a machine will work that some part of it will not generate heat, of course. But what we are saying is that the heat that it will generate must be machinery friendly. That will be friendly to that machinery. Of course, as human, our body generates heat. So your body must not generate too much of heat in such a way that your internal organs would not be able to bear it. So if you as a human being, you understand that. So think about machine also. A machine also, definitely when there are moving parts, there is no way, no matter how you work on reducing the friction, there will still be some level of heat in the machine, but it has to be friendly to the machine. Okay, we may also discuss in your maintenance, you must have seen different kind of lubricants being used. There are sometimes some machine actually make use of oil, lubrication, and all these things. When you pay attention to most of those machines, there are peculiarity of machines that use oil for their lubrication. For example, if you see most of these heavy duty machine, like your tractor, okay, like your forklift. So when you see them, you see that most of them make use of hydraulic as their power source, and anything that is hydraulic is oil. Oil is actually the one that is generating power there. So when you look at most of, I show you the example of I show you the picture of tractor, the forklift. I show you the example of all those ones yesterday. The car lift and all that, they use oil because they work on hydraulic, and oil is also used to actually lubricate them. When you look at some machines that make use of grease, okay, there are some machines that make use of grease for their own lubrication. So you can use grease if the moving part in that machine, or the part that is supposed to lubricate, if it's not easily accessible, it's not something that you can be accessing from time to time, you may have to actually use grease, to actually grease that part, since it is a place in the machine that you cannot be going there frequently for you to actually lubricate. So there are some machines, this will actually sound funny, hardly will you see a machine that use water as lubricant. But we also consider in maintenance, we consider water to be a lubricant, because definitely what lubricant does is to, part of the work that lubricant does is to remove heat. Water can also remove it, especially in human body. Our own lubricant. Many of us don't know that human body also have lubricant, and our lubricant is the water in the body. That's what is lubricating your elbows. If you have seen the anatomy of human being before, the skeleton of human being, see the body of human being is made of bones that rotate on another bone. So when you look at all these joints, your spinal cord, your tissues, water is the lubricant that you are making use of. We also have some machines that make use of gas lubrication. When you're talking about pneumatic powered machines, anything pneumatic, when you hear the word pneumatic, it is air. And when you hear the word hydraulic, it is what? Oil. So the pneumatic, you know, there's some machines that use what? Gas as their own what? Lubricant. We have some cooling system also. I've mentioned the one of what? Air cooling system. We have the water cooling system. We have some that also make use of oil to cool down. We have evaporative cooling. And the last one is what? Heat exchangers. Of course, if you know the working principle of your air conditioner and your fridge and your freezer, these actually make use of what? Heat exchangers. Your AC in your room, you will feel cool inside the room. But what happened? So the AC is just extracting the heat is being what? Evaporated out. That's why when you go to your radiator outside, you see that what? It will be hot outside and inside will be what? Cool. It's just extracting the heat. What is that particular, you know, coolant? What is that coolant inside it? It is what? Gas. So when the heat inside the house heat up the gas will what? Expand. And then when it goes through what? The circulation, it will what? Reach what? The outlet of the fan. The fan will extract it. That's the radiator fan. We extract it out. Those heat will escape through the what? Radiator. And then the gas will go again, get heated up again. The heat will be what? It will be extracted out. The gas will circulate again, get heated up again. Why is it becoming heated up? Your breath inside the room, the little heat that is inside the room, until the temperature of the room actually drop. And then you say that what? It is cool inside and hot what? Outside. So what is the best practice when you are dealing with lubrication and cooling system of a machine? It's very important, especially I'm already talking about the mechanical aspect of what? Maintenance now. So what is the best practice? The best practice is regular maintenance. That's preventive what? Maintenance. There is no maintenance that supersedes preventive maintenance. And this is the problem of industry. I discuss with, you know, the problem we have is people's orientation. Most of the problem and the downtime across industries are human what? Caused problem. Why? Because of the attitude of people towards maintenance. The first is attitude of people towards the work. Many people don't like the work that they are doing. And when you do not love your job, you know, there will be every tendency for you to actually what? No. Your integrity will be dangling. A lot of people are like that. Most of the factory workers, perhaps most of them are not really happy with the job. And this is part of the advice we normally give you know, most of these factory manager. People should not be overused. There are some companies that use the same staff they are using for operation for maintenance. That's practically wrong in the industrial setting. The people that will be in charge of maintenance should be in charge of maintenance. And people, yes, I explained yesterday that what there are some level of maintenance that what the operator of the machines, the operation guys can do on the machines. But this is different from what the preventive maintenance. Some operators of machines, they can actually repair their machines. I know many people that they become what their own car mechanic, and they never learned any mechanic work anywhere. It's just based on their experience in driving a car. So once the fault happens, they are already conversant with what could have gone wrong. So even when they are calling the mechanic, they are telling him what to do. So you cannot come and do that kind of people. They understand the machines that they are using. That is, they understand the car that they drive. So there's an operator like that they do not learn how to repair the machine, but because they have been operating it for a while, they know how to bring it up when it actually what goes down. So in the case like this, an operator or the guy in charge of operation can actually what help when it comes to corrective what maintenance. It may help. When it also comes to condition-based maintenance, an operator can actually what do that. You are the one running the machine, and then you observe that what, oh, physically observing the machine, you see that what this machine is not right. Something is wrong somewhere. Even though the machine is still forcing itself to work, it seems like everything is okay? You can look at it and say, oh, something is wrong somewhere. And then you want to actually what? Shut the machine down. You call the necessary authority, you inform them that please, I have to shut this machine down and quickly do this. They give you go ahead. You can do it. But the preventive maintenance is for what? Especially what? Trained people. That's what I'm saying. And that's the regular maintenance. You know, regular inspection, regular lubrication, regular improvement on the cooling system or monitoring the cooling system. It is very, very important. That's the best practice, okay, for lubrication. Another thing is that when dealing with lubricant and cooling system, you have to be careful when you are selecting what the lubricant itself. Many of us don't know that you know, the best lubricant to use in Toyotas is for you to actually buy, you know, there are specifically recommended what lubricant every manufacturer. Okay, it was the day I used what I bought I went to a mechanic workshop, and they just told me that, oh, they have to change this oil. And meanwhile, it was an emergency breakdown of my car that made me to go there. He is not really the one that normally work on my car. So when I got to the actual workshop where they normally maintain my car, and I told them that they changed the oil, the guy in charge of my car was very, very angry. Then why didn't I call him? You could have come from those or speak with them before they changed the oil. In fact, I was so shocked. Because I actually bought a very good product. Well, he said that was, yes, it's a good product, but it's not the one that is recommended for my car. So a lubricant might be good, but is it the one that the manufacturer actually recommend for that machine? So you need to check the manual and be sure that what the lubricant that you have chosen. Many companies don't do this. They just say, oh, that's what we use, and then they begin to put the, and the repercussion is that it will definitely affect the lifespan of the machine, whether you like it or not. This person must be eating rice. You said because beans is sweet, or you go to hospital, they said you should not eat this kind of food again. The doctor said based on your health, you should not eat this kind of food again. It does not necessarily mean that the kind of food they ask you not to eat, they are bad. No, they are not just good for your health. Other people will be eating it and it will be nutritious to their own body. But for you, it has become something almost like a taboo or poison in your own body. So you should avoid it. So that they said that you should not eat beans again does not mean that beans is bad. Beans is actually good in its own. So some lubricants, it's not that they are really bad, even though there are some that they are actually they are fake of lubricant. I know somebody that is into oil, not this lubricating oil business, and he told me so many things about how people actually make the fake of all these lubricants. The fake of most of these lubricants are very, very common out there, and they will even label it like a known product. So if you care so much about the maintenance, you have to be really careful when you are selecting your lubricating oil. Okay, so proper selection is important, monitoring is important. Be sure that there is no contamination on the oil. That's another thing. There should not be contamination. If little amount of dust should actually pour inside the lubricating oil, trust me, it can cause problem in the machinery system when you pour it in. If there's a little amount of water that mix with it and you still pour it like that, trust me, it will have a negative effect on the machine. So it is very important. Not everybody can also lubricate machine. People should actually be trained. It is a simple thing, but you have to be trained. Like why I'm saying that you need to be trained is that it takes people who have actually, let me show you something. Let me relate something with you quickly. It takes only people who have been doing this to actually know the repercussion and to adhere to the instruction of the manufacturer. Many of us have seen this. If you have seen this in some mechanism before, you let me know. I want to draw something. So if this is where you need to actually put the lubricating oil, okay, when you watch very well, the container can be as, as much as this. You will see low. In fact, in your car, if you check your engine, that's where we have what the gauge. Okay, if you check the engine oil level, you will see that what even that gauge that you are using is actually being marked. You see the mark here, you see the mark here. That is what this is the lowest level that your oil should be, and this is what highest level. Because you have money, I say I have money now. Why should it be there? And then you pour the oil, until you reach this level. You want to kill that machine. That's what you are going to do to that machine. So it's just like overfeeding a child. Okay, this is the amount of food that this child should eat. You said because you are a rich father, and then you want to show that you're a rich father. You said instead of taking 1, take 3. That's an overdose for that child. Or the doctor said that we should take 2 paracetamol. You said that the headache is too much, and then you carry 6. You use 6. So just look at how you are going to feel in your body. Then now translate it to machine also. The oil level, you have to check the level it must be in the mechanism. So they always mark it, check it very well. Any machinery that you see where you have to put the oil, there are always guidelines on the level of the oil. The container don't be deceived by the container that it's very big, it can overflow. That's not what they are saying. Because why you have to put this level is that what when the oil is actually heated up, it will still expand. The viscosity will reduce, it will expand. So the allowance has been given. This allowance you are seeing up here has been given for the expansion to occur. So imagine that when you feel it here, what will happen if the oil is actually heated up? There will be spillage, and this spillage, I've heard of somebody before that oil actually spilled and entered the dashboard of his car, enter everywhere in his car. That might not actually be because of the too much of oil, but that it must actually be something. The oil mechanism in the car, either it is not well tightened, either it overflow or anything whatsoever. So you must always check the level, and that is why I was explaining that the personnel that will do this must be trained. You can't just say anybody can just carry, just go and gauge the oil of that machine or of that car. You can kill that particular machine. It is somebody that is experienced that can feed a baby. So just see it that way. So people must be trained to actually do that. So you monitor and then you train the personnel. So what are the consequences of poor lubrication and cooling? Equipment failure. There will be equipment failure. Of course, that one is guaranteed because there will be wears and tears. Too much of heat in the system will make some part of the machines to damage, and it will definitely break down. The efficiency of the machine will reduce. There will be wears and tears. And most importantly, there will be risk to your health as a person. Even there will be a negative impact on the environment where you work. So all these things are very, very important. There are some parts of the machine that if you do not actually maintain them, instead of the noise level to actually be low, and the machine is not making too much of noise, whose ears will it affect? It will affect your ears because there are some operators that stand with their machine, 95% of the time they will use in the factory to work on that day. They cannot leave that machine because they have to be on observation, even when they have already set the machine to work. So imagine that you stay with your machine. Let's say you are even working 7 to 7. There are some shifts that are 7 to 7 work. Okay, that's like saying 12 hours. You are using 12 hours to actually work. So if you use your 12 hours to listen to a higher noise that is higher than the level of decibel that should actually enter into your ears, and you do that every day, you can imagine the damage that will actually cause to your safety. So it is very important for us to look at this. Now, the next thing we want to look at in our industrial maintenance, machinery maintenance, is for us to have an overview of some tools. Some tools that you you will need for your maintenance. It is very important. Anybody here who normally perform maintenance on machine? Do we have people here that perform maintenance on machines? Please signify. If you know that you have performed maintenance on a particular machine before, signify. Anybody? Any maintenance engineer here? The machine that you use, those who that spoke to me in the last class, you don't perform maintenance on your machines? Okay, is there any engineer in the house? I'm going to call people myself. Okay, is there any engineer in the house?
Yes, sir.
Okay.
Abdullah, yeah. Okay. I think you will drop his hand now.
Engineer Abdullah, is that Abdullah? Who said yes, sir?
Engineer Daniel, sir.
Okay. Thank you so much. So, you perform maintenance. Tell me some tools that you use during your maintenance. What are some tools that you normally go with when you want to go and perform maintenance on a machine? Are you there?
Yes, sir.
Tell me some of the tools that you normally use for your maintenance. Or you are not in the
Sorry, can you hear me? Can you hear me?
Are you?
Okay, all right. Yeah, we can use stethoscope for testing for
What's the job of your work?
electrical engineer, maintenance engineer.
Mechanical engineer?
Electrical engineer.
Okay. So what do you use in your own maintenance? What are the tools that you use?
I use stethoscope for testing for noise level of motors. I also use infrared cameras for testing for temperature of motors.
Good. I love that. Thank you. I love that infrared that you even mentioned. I love it the more. So, any other person?
Yes, for electrical motor. Hello.
Dave, can you hear me?
Mr. Moderator, is our class on record?
Yes, our class is on record.
Okay. Who else?
Yes, I can see your hand. Thank you.
Can I go ahead? Yes,
I will mute. All right. Good evening. Good evening, Mr. Presenter and the moderator. Yeah, I'm into biomedical engineering, and the equipment usually, or the tools, sorry, I usually go around with for my maintenance, the routine maintenance, is usually my digital multimeter, my Allen keys, and touch keys. Sorry.
Thank you so much. That's detailed. Thank you so much. I appreciate you. So that is exactly what we wanted to do now. We'll just briefly look at those tools. Of course, they are not things that we should too much on. Can you hear me?
Yes, we can hear you. Yes, we can hear you.
Yes, we can hear you.
Can we hear me?
Yes, we can hear you.
Go ahead, sir. You are audible.
Okay, thank you so much. So we'll look at those tools. The first set of tools are your hand tools. You know, these are your hand tools. Wrenches, okay? Some of your wrenches can be adjustable. You can have the socket one. You can have what? The box head. Some people use pliers. I think plier is a very common hand tools during maintenance that we use. And we are talking about all types of your what? Pliers. There are still some engineers that I see, electrical engineers, that use their teeth to peel wires. It shows that what? You are not trained or you are quack. Okay? It means either you are quacked or you are not trained, because it's not a proper practice for you to use your mouth to peel wire. So you need to use your pliers. Okay?
Very clear.
please mute your line. Who is that?
You can proceed, sir. I think that has been resolved.
All right. So we have wrenches, pliers, screwdrivers. And when I'm talking about your screwdrivers, I mean your flathead and your star screwdriver. There are some people that use the set of what screwdriver. That is better because it makes precision. It gives room for precision when you need what to use it. So hammers. Yes, somebody said most of the time you have to come with pliers and screwdrivers. Yes, they are common tools. Some people go with hammers, especially the mechanical guys. I've seen them a lot. Maybe you want to, there are some joints that you need to, the way they do it, they put something like a chisel on that joint part, and they have to use the hammer to hit it so that it will come out from the other end. So use hammer, some use tape measures and levels. You have to check for their oil level, coolant level and all that. Some make use of the utility knives. If you have seen utility knives before, let me see. I think I have a collection of some pictures. Okay, I was thinking I have those pictures. So you see some set of pliers, screwdrivers, utility knives. Utility knife is for, you can use utility knife for those that normally use their teeth on wires. Utility knife, you can use it to actually peel off the insulator of your wire. There are some wire that you may not be able to use plier on. Okay, maybe because of their thickness or because of their thickness or the kind of conductor that is in them, you may not be able to use pliers. So use your utility knife. It's just as if you are sharpening the mouth of an arrow. That's the way. Okay. So you also make use of cutters. Some people think that pliers can do the work of cutters, but in most cases it is not so. So the cutters actually specifically they are meant to actually cut. Okay, pliers are meant to twist, but some people are good. There is a smaller part of the plier that you can use to cut. But if you really want to do the work of cutting during maintenance or installation, then you need your cutters, strippers, socket set rather, the racket. Your power tools, we are talking about drills, we are talking about your grinders, we are talking about your circular saws, rotary hammers, okay? Some specialized tools that you also use, your multimeters. Okay, this is the one of the practical that I'm going to be having the demo with you is on multimeters. Okay, I'm actually pushing that one to be for our class tomorrow, like the hands-on. That one will look like hands-on. It should feel as if you are doing it with me in the class. Multimeters, your oscilloscopes, my friend mentioned the infrared thermometers. Okay, you will see if you have some materials that are being transported on a conveyor belt or that will flow through conveyor belt to another processing unit, and you really want to monitor their temperature, okay, you can use all these infrared thermometer. There are some that are handheld that you just come and will use on it, but there is one that is called pyrometer. I think I'm correct, pyrometer. So that one is actually attached. So at distance, from distance, it can actually take the reading of the temperature. So for leakages, you can use ultrasonic leak detectors and vibration analyzer to actually measure the vibration level, pressure gauges are there, and all this. So we have all these equipment. The other aspect of maintenance that we need to discuss is the safety aspect. And in most cases, this is actually underrated. Even many guys that are good in maintenance, they overlook these aspects. And I can tell you that I've seen a whole lot of people. In fact, the only thing is that I can testify that I also have a direct experience. But my own direct experience is not like that of some of my colleagues back then in industry who actually was God actually saved them, narrowly. They could have actually passed away just because they wanted to perform maintenance. And these are the things that you should pay attention to. The safety aspect of maintenance is very important. When you're going for your maintenance, okay, let me make people to contribute on this. What do you actually what are the things that you do as the safety aspect of your maintenance when you're going for your maintenance? That my friend that mentioned the electric motor maintenance. Is it Daniel? Engineer Daniel? Are you there?
That's Daniel Chinidore.
Okay. So what do you do in the aspect of your safety when going for your maintenance? Are they there with us?
Okay, maybe I want to call. Can I call in from there?
Can I talk?
What are the things you put in place for safety when you are going for your maintenance?
Yes, you can unmute and respond.
Good evening.
Is Jeff there?
Can I answer?
Okay. All right.
Good evening,
I
sir.
should go through Engineer Daniel one part. Charlie, what? Can you hear me?
I think we are using through another device on you.
Hello. Okay. So usually, what the important thing to do is to cut the supply. If there is any power supply to the equipment, the machine, we should be able to sign, stack out, so that the equipment is working, so that nobody goes into to power on the machine while we are running the maintenance on it. So we cut every supply that goes to the machine. That's number one. Number two, we should also do well to clear the workspace, that's the area.
Okay.
Any hazardous material.
All right. Thank you for your contribution.
Okay. Affect so any accidents, let's put it that way, industrial accident.
Okay. Thank you for your contribution. I really appreciate it. Thank you so much. Abdul Karim, do you still have a contribution? Okay. So these are the materials, your PPE, okay, that you should actually put in place when going for, depending on the kind of maintenance that you are doing or the machinery that you actually want to maintain. Your hard hat and safety glasses, okay, your ear plugs and ear muffs, depending on the level of what noise, okay, the level of noise. You use your ear plug, you use your ear muff. Your respirators or your dust mask. I remember back then we used the dust mask. That's what we do because I work in a cement factory. Your safety boots, okay. If you know that the illumination level of where you are working is low, you have to wear your high visibility vest that we call or reflective jacket. In other words, if you are working at height, then if your maintenance is being performed at height, your safety harness, okay, you must actually use it. Your first aid kits when you are working on your maintenance, make sure that you have first aid kits, close by in case anybody sustain minor injury, cut and all that. Fire extinguishers in case of a fire outbreak. Fall protection, your harnesses, I've actually made mention of that. So all these are very important. I'm still going to talk so much about what the safety aspect. So what is the guideline? Every maintenance engineer must learn about safety. It is very important, and they must be ready to follow it. They must know the right PPE to use, and they must know how to use them. In our safety training, we train people on how to rightly use their PPE. It is very important. It is wrong for you to wear your helmet, you are wearing your helmet backwards, or you wear it sideways. Helmet should actually be worn in a way that it will protect your head and not just to beautify your head. So it does not matter how you look in your helmet, but what matters is how safe your head is inside your helmet. Likewise, your safety boots. Your Timberland is not a safety boot. That you have a very big shoe that look bogus. It does not represent a safety boot, because a safety boot is protected. It has it is laced with metal to protect your toes from fall and to protect your foot from anything that can puncture you when you step on it. So it is important that in the maintenance environment, thank you for that contribution. It has to be cleared. You have to tidy up. If there are iron filings and all that, you have to pack them properly, because anybody can step their foot on it. So I have all these, your head protection, either bump caps. If you go to some food processing company, you will see that the kind of ones that they wear is they are like air nets. That's to protect the integrity of the product, so that there won't be contamination in the process of making it. So all these are very important. So we have it covered. Of course, like we promised, you are going to have this material. So we have it covered. So that will make me to talk about the major aspects when performing the maintenance, which affect the safety and which is part of this process, and that is LOTO. And that's what our contributor, the engineer that just spoke, actually contributed on. That they will actually follow the LOTO process or the procedures, so that there will be the safety of the maintenance guy will be guaranteed. Now, what is LOTO itself? So we use LOTO to actually secure the lives of the maintenance team in such a way that there will not be accidental startup of a machine when they are working on it. We use LOTO to prevent a machine being accidentally started while people are working on it. Okay, so let me do some analysis. Let me share my whiteboard. Let me do some analysis. I hope you can see this. I hope you can see my whiteboard, right?
Yes.
Yes. Yes, your whiteboard.
Lock out, tag out. Now, in most industries, when you want to work on a machine, you already know that this machine, is being powered up. Is using electrical power. It is wrong for you to perform maintenance on a live machine. A live machine means that this machine is still being powered up. So this is a live machine. So what do? You have to go to the electrical department, or I don't know the procedure in your own company, but in the company where I work, they will come to us in the electrical department, and they will tell us that they want to perform maintenance. As an electrical person that is also in charge of this, you dare not go and shut down that machine. You have to first confirm. Is it the preventive maintenance they want to do on the machine, or the machine actually ran to failure, or the machine actually will fail on its own, I mean. So if it's preventive maintenance, you must have known. If they are using CMMS, electrical guys, they will have access to this CMMS for them to check that it is true, this machine is due for maintenance. You see the advantage of electronic schedule maintenance. So electrical can actually see it, and what electrical will give you, they will give you a form to actually fill. So in this form, when you fill it, there will be duplicates, just like your bank teller. So there will be duplicates, and this duplicate means that what? A copy will be given to you. So you hold it as an evidence. This evidence is against the electrical. I actually came to you to collect what? Line clearance. We call it line clearance. So you as the personnel that want to go and work on the maintenance, you need to hold this paper. A copy will be with you. In this paper, what would they write there? The machine you want to go and maintain, your own name, the name of your department where you are from, and the duration you will use on the maintenance. It is very important. You can't do maintenance forever. If it's 1 hour, it must be specified. If it's 2 hours, it must be specified, so that you know what, how long you have to work on what, maintaining what, that machine. It is very important. So it will be specified. The time you are going to use on the machine will be what? Specified. And then you hold what? Your own copy of the paper. So the other copy, okay, there will also be a duplicate that will remain. You know, it's just like a bank teller, the way you tear it out, or the way you give people what? Invoice. Okay? Or you give people what? Receipt. And then you are keeping some duplicate with you that is what? An evidence. So the electrical guy will follow you to the machine, and it is compulsory. I don't know the procedure, but the practice and the standard is that what? Do not collect that paper and go and start your job. No. Follow him to the what? To the breaker or the circuit breaker of that machine. So in your presence, they are going to power this off. This is the power source. They will power it off. When they power it off, they will put this tag, the copy that is bringing, this copy, they will put it on it. This tag shows that what? Men at work, or so electrical guys at work from so time to so time. So the paper is there, so that anybody that comes to this breaker, they will see this paper there, that people are working on it. Now, what happens? What if we have a crazy person that is impatient to read what is in this paper, and the person now open what? The breaker, and just power up, and you are on the field working? That is why we now have what? This paper is the tag out aspect. The paper means that what? You tag it out. The paper that you put there is the tagging out. The lockout now says that what? Even after you have put the paper, you need to secure this what? This breaker with a padlock. Put a padlock there, lock it up in such a way that what? Anybody that comes there, even though it's crazy enough to remove this paper, of course, when it's about to open what? The breaker door, you will see that what? It has been locked. And they will give you the key. That's the wrong aspect I see, the wrong practice I see in somewhat industry. The electrical guy will not go back with the key. No. You that want to work on the field, you have to actually what? Go with the key. You keep the key and you bring it back to electrical when you are done. So that when the key is with you, you are guaranteed and you are sure that what? Nobody can start that what? Equipment. Now, another thing, if you have that what? Benefit in your company, also use this that I want to talk to you about. Now, when you go to the field, you will see the push button to start what? Machine. This is usually big. So this is actually what? The green one, which is to start. This is what? The stop. And this what? Is the emergency. If your company is fully automated like the one I've worked with, you know, most of the companies where I've worked, they are fully automated. It means that what? They do not have to come to this what? To this push button. They don't have to come there. Somebody just sit down there in the control room. They sit in the control room and power up what? This machine. You know, distance starts. They will start it from a distance. So what happens when you come for maintenance? As an electrical person or as a mechanical person or whoever, as a maintenance engineer, when you come to the field, even after you have taken what? The line clearance, they have padlocked it, they have done everything. Please, when you come to the field, make sure you activate this emergency what? Switch or this emergency button. You know the use of this emergency button? It means that even if they want to power it up at the control room, the machine will not start. This actually cut off what electrical supply to this machine. Is an emergency button. But the only fault that many maintenance guys normally have across industry is that when they are not done with the maintenance, many of them will forget to release this emergency button. And it will eventually lead to downtime. Because by the time you did not release this emergency switch, and the control guy in the control room is not ready to start, they will have programmed it that this machine must start by maybe 8 p.m. Imagine you want to start by 8 p.m., you will be seeing the error. Error will be beeping on its own system, showing that there is an emergency switch already activated on this machine. The time that you will use when they call your department, please, the machine that you maintained, you forgot to actually release the emergency switch. The time you will use to run from your office, because in most cases, especially if you work in a large factory, I work in a large factory, where it will be, if you are going from one line to another line, it's as if you are traveling, even within the factory. Especially if you do not have operation vehicle. The time you will use from your department to go and release this emergency switch, trust me, you have used 10 minutes. That 10 minutes will be recorded to your department as downtime. You are the one that caused that downtime. And you know the millions that you have lost. So, but all this actually help you. If you activate the emergency switch, remember to actually release it in case when you are done. So this is how actually Lotto actually works. So you log out, you tag out. You must tag out, and then you must also lock it. And then personnel must be trained. They must be trained on how to carry out. Okay, the personnel must be trained on how to carry out Lotto across industry. It's very, very important. Let me share this now. If you understand what Lotto is now, please, you can give me a thumbs up. Give me thumbs up if you understand what it is now. Good. Good. So if you have been doing it wrongly, please make sure that you care so much about your own life, and then you go and correct it. So thank you so much. I love the thumbs you are giving me. So that is what Lotto. I don't want us to have actually broken it down, and then you have this. So I explained this also yesterday, that on every machine there must be hazard identification. So you must actually identify the hazard attached to a machine, so that you know the level of risk. You know, when it comes to working on that machine, what is the level of risk? Now, in calculating the risk aspect of a machine, you have to assess what is the probability that the harm from that machine will occur, and if the harm from that machine occur, what will be the severity? Let me give you an example. Okay, I will use one person to assist me with this. One person that wants to volunteer. Don't worry, you are not doing anything for me. It's just like you are just backing up. Anybody that wants to signify to be my partner on that? Mr. Moderator,
I can and are you willing to support to help the trainer in this aspect?
Thank you so much. Thank you so much. So let's say we have a machine. What we want to discuss is for us to know what we talk about, risk assessment. Okay, very briefly. We don't need to waste time on it. I just want to give us a brief illustration about it. So this is a machine, and then we perform hazard identification on it. We see that this part of the machine can cut somebody, and this part of the machine can also cut somebody. Let's say part 1, part 2. Okay, so the part 1 can cut, part 2 can cut. Okay, so this is what we now do. That I'm saying, we are going to know what is the probability Many of us, you know, in our math, we do probability. What is the likelihood? We know that what this thing can cut somebody, but what is the likelihood? What is the percentage assurance that what it will eventually cut that person? And now, if it caught the person, what will be the severity? How severe will it be?
Okay.
Are you with me?
Yes,
so we rate probability from you know, in percentage, or we can say from 0 to 1. Okay, 0 point something to 1. Or let's just say percentage. Let's say the percentage that was this one is a cut. Both of them, they are cuts. The harm that they can cause is of cuts. Okay. This one is 60%. This one is actually what? Just 20%. This cut can also happen, but this one, 60%, we know that what if you cut the person that is operating the machine. This 20% that you cut the person. Now, if it cut the person, how deep will it be? That is the severity. I'll be asking my partner now. Can a knife cut somebody? My partner, can a knife cut somebody?
Yes, sir. Sir, you can.
Okay, knife cut.
Yes, sir.
Okay, knife cut. Can a sword cut somebody? Sword for war?
Yes.
Okay. If they give you, none is good. If they give you a type option,
Yes,
which of the cuts will you rather go for?
The knife.
I'll prefer go for knife cut.
Knife, why? Why?
Because the severity of the knife is
God bless you.
not do as much as that of the sword.
The severity, yes. If the cut happen, which one will be worse? Okay. A blade
That was
can
the
cut
sword.
somebody. When blade cut somebody, it is different from when knife cut somebody. It is when knife cut somebody, it's different from when cutlass cut the person. When cutlass cut, it's different from when sword actually was cut. So you must talk about the severity. And we use the word low, either low, or we use what? Medium or high. Let's say in this case now we say that what? This would be what? High. So in this place, it really shows that what the probability is high, right? But when it eventually what happen, it will be low. In this case now, you can say, let the person wear what? A PPE. Maybe you should use what? Hand glove. Are you getting my point? So we use probability risk assessment to pick what will be our solution on the machine. Can we work with the machine, or we just have to write off this machine? It is the risk assessment that will show us that. If the probability is what? Is high, but the severity is what? Is low. We can tell the personnel to actually what? Wear PPE. Is that not so? We know that what? It will just be little cut. And if you wear your hand glove, definitely it will not actually what? Pierce into your skin. That one is noted, right? But look at this one, 20%. 20% is still considerably what? High. But when it happens, let's say this kind of high, the severity is that what? It may chop off the hand of the person. Wherever the contact of the person, whatever the body of the person that make contact with the machine at that time, it will actually what? Cut it off. You see the severity. That is high. And that's what we'll now be talking about what? Hazard control. So the risk we actually will let us to know that what? Okay, fine. Which of the hazard control should we actually what? Apply? And hazard control looks like what? A cone. Okay? You travel down to narrow down. The first one is what? Elimination. The next one is substitution. Okay? Can we actually what? Eliminate? Can we substitute? The next one is engineering control. Okay, if we cannot do that, can we use administrative measure? Administrative measure. Or can we just use our PPE? So depending on what you actually have on grant, there are some level of what hazards that when you do their risk assessments, so you cannot go ahead. So that kind of machine may be very dangerous to the what? To the work environment. And then we have to what? Eliminate. So we check the hazard if we can what? Eliminate it. Elimination means that what? Can we avoid it? That part that is so dangerous, is there any way we can eliminate it? In most cases, it is what? It is, almost not practicable to eliminate hazard or to eliminate all hazards. It is almost what? Not practicable for you to be able to eliminate all hazards when it comes to a machine. There will still be what? Hazard. But one thing that if the risk assessment is showing us that what? The severity is high, the probability is high, then we have to substitute that machine. Substitution means that what? We have to find another machine, another type of machine to use. And I told you of a company where I work, where they have to change all their generators. They have a reason for it. It may be economical reason, okay? Because it's also hazardous to us to be spending too much, to be wasting power. Perhaps maybe the machine we are using before always, have a lot of rotating parts. They always generate high watt friction, and is consuming what? Lubricant and all that. And then we have to find another machine that can consume less. That is substitution. We substitute it. Engineering control is that what? If the heat is the one that is too much in the machine, can we get some cooling fan? I've seen in some industry, even though it's not the right practice, some electric motors that they have run them for a very long time, and now they are now overheating. You will not see them. Some of us here that have seen such before, they will just be laughing underneath. They will not carry all this aux fan. They will go and power aux fan and center it. This is not in the manufacturer it's not in the specification of the manufacturer. But because they still need that electric motor in that session, and they are not ready to shut it down or replace it, they will not carry aux fan so that it will be blowing it, to reduce the heat level. It's part of engineering control. The cooling fan is part of engineering control. If you see a rotating part that maybe is exposed, you can build a guard around it to cover it, such that the hand of the operator will not be trapped inside. That's what engineering control. Administrative control is by you implementing some policies. Like we are mentioning about Lotto. Lotto is a policy. The company are so strict with it. Wearing of your PPE is a policy. There are some companies that you will face disciplinary committee if you are being snapped. They will snap you. The safety personnel walk around in the factory. So when they see you in a dangerous place without your helmet, where you're supposed to use helmet, they will just take your picture. And when they invite you to a disciplinary committee panel, they will just show you your picture. What are you doing in this session without your helmet? And if you are being called more than once, it's possible that you are sacked based on that. That's an administrative measure. Administrative just mean about the rules and regulation of the company in order to reduce risk or the hazard, or you interacting with the hazard in the factory. So it's just for you to adhere with the safety. It goes beyond that. And if we now see that we have tried this one, the last result is your PPE. After we have tried the rest, so maybe you should wear something that will protect you, so that you will be you will be safe. Let me stop there tonight. I think I've covered much. So tomorrow I will move briefly to just mention more of the mechanical. Okay, more of the mechanical, yes, and then we'll talk about the rest. So what I've just explained is about the risk assessment. So I've covered that. And then, yes, we have a whole lot. So we're talking about electrical safety principles. So tomorrow I'm going to be starting my class with this. talking about what? The principles of what electrical work safety when it comes to maintenance, your grounding, your insulation, your circuit protection. We have mentioned logger tag out. I'll be talking about what earthing, grounding, the difference between them, your regular maintenance, your electrical safety devices, you know, and all that. So we'll see how far we can go tomorrow. And I really want to actually give you some sample of how questions on industrial maintenance also look like. So we'll test run what we have actually learned so far. If we can actually do that before you do your assessment, let's see some questions that we can answer and all that. So we'll test run. So Mr. Moderator, over to you. I really want to give people room to ask me questions.
Okay, thank you very much, Mr. James. It was a wonderful class. Okay, so let me go back to my normal screen. Okay, so we thank our trainer, Mr. James, so far. Actually, it was a recorded class. So it's now time for questions. A lot of things were said in the course of the class. Okay, so from our comment session, someone is saying, please, can you repeat the MTBF in brief? Okay, I suppose you weren't present in yesterday's class, Mr. Yakub Abdullah. Nonetheless, okay, so please, let's quickly, we'll take note of that. So please, let's quickly go to questions. So please, if you have your questions, please signify by raising up your hands so I can call on you. Okay, so questions, keep it coming in. So let me see your hands so I can take note of those who have questions that we can attend to. Okay, so let's go with Ebute Bartholomew. Ebute Bartholomew. Hope I pronounced your first name properly.
Good evening, everyone.
Yeah, good evening.
Okay, my name is Ebute Bartholomew. I would like to say that I really enjoyed this class, and this is I mean, a very nice work that is being done here. It's a welcome development, and I thank the organizers. So my question will be on the risk analysis. I didn't get that part. I'd like I would like a few moments of explanation on that part again, so I can understand it very clearly. Thank you.
Okay. Thank you very much. So I have our trainer, Mr. James, is going to attend to that question. Any other question, please? So if you have your question, kindly signify by raising up your hand. Okay, so Mr. Charles, busy. Sorry, I murdered that name. I know I didn't pronounce it properly. So please, can you unmute your mic and ask your question? Charles, are you there? If you can hear me, I can see your hands. So please unmute and ask your question. Rofiu Iroko. Okay, you can go ahead.
How can we have access to the yesterday's lecture for which we are not present?
You're on the WhatsApp group. We dropped the link to the yesterday's class on the WhatsApp group. So, and if you can't access it there, you can go on our YouTube page. Just go under the live videos. You'll be able to see the first class for industrial machinery maintenance training. Day one, you will see it as that tagline. So you can, but we dropped it on the WhatsApp. We just go back to the WhatsApp messages, scroll up. You should be able to find the link to the yesterday's class there. Okay, so
I still drop it today, even close to the time we wanted to start the class. Just go to the WhatsApp. But if you cannot find it on the WhatsApp, just send a message on the WhatsApp that you need the day one class. I will just quote it for you.
A repeat of the classes will be dropped today, actually. So don't panic. So just be stick to the WhatsApp platform to get those information. So let me allow Mr. James to give a response to the first question. And Mr. James, over to you, sir. Okay. Before you take the question, let me quickly take orders. Christopher Oladosu, you have a question.
Yes, sir. Good evening, sir. Good evening, everyone. Thank you very much again today for this session. Very educative. I learned a lot. So my question goes thus: that is there any way the management can just assist us to extend this training or this class for probably a week? Because going by all the content of the training course, I don't think 3 days can be sufficient to even cover let me say like 60% of this training, going by what I saw in the content. So if at least they can help us extend it to, like, let it just be run from that Sunday to Sunday or from Sunday to Saturday. I'm not, I'm just suggesting and I'm appealing if they can just assist us, and it will go a long way, helping us, because if that content can be achieved 70%, if not 80%, I think it would be so beneficial. Please, they should just help us, consider this. Thank you very much.
Okay, thank you for your.
I will address that, Mr. Moderator.
Okay, go ahead, sir.
All right. So let me first take it from the first question. So I will run through his own question too. Would that be okay?
Yes, you can go ahead.
Okay. So the first question, I think the first question also go with the second one. One thing that you should see is that we are just using our area of expertise to undo most of these professional courses. Number one thing is that the people that we are training, just like you also, we know that you are in the field and most people are actually, busy with work and everything. You even see that some are not even live right now. They will have to go through the class that has been done, maybe after we drop the link to the class and all that. So one thing I will implore you, I'm answering the first question with the second question, actually, but I will still be specific on brushing through the first question. One thing I will implore you is that you have to go back to this class. There are people that the way they learn, they cannot just take too much. When you see what I covered within these 2 hours, trust me, what I covered there is something that, if we are in a physical class, 10 hours, we are talking on it. But why it will be like 10 hours is that maybe I will be pausing, I will be stopping, they will go and ease themselves, people can stop me along the line and everything. So you have to go back to this class. So it's just like too much of information at a time, just coming to you. That is why you are saying that maybe it can be extended to 7 days or anything whatsoever. We are actually using expertise to break it down bit by bit. And of course, another thing that you also have as a chance is that when you go through the class, we are still very much available on our platform for you to send in questions, even if you have challenges in your area of maintenance across your industries. So we are open to that. We always do that, just to mentor you and to solve problems even after the training is been done. But when you look at it, yes, you are very correct. When you look at, don't look at the bulky materials. You can see like 10 pages on my screen, and within 5-10 minutes with good illustrations and instructions, I could actually explain what you could be going through in that 10 pages or 12 pages. That's why there are practical illustrations. If you observe, you see that I use practical illustrations within the explanations. These practical explanations are to help you, assimilate, so we are not here for me to be going through the slide and just be reading it. That would be very, very boring for a lot of us. But the explanation, the practical explanations will help you to connect with the class. So if I will indulge you, Mr. Christopher, specifically, and every one of us, let's go back to the class. Don't say you you are present on the live class. There are a lot of things that along the line during this live class, maybe you were distracted along the line or your network was bad along the line, that you may not actually catch up with. Just like what Mr. Ebutemeta just asked. I did, break down that risk assessment, but maybe while the class was on, maybe he has issue with his network, or along the line he had to quickly switch to something he couldn't get. So please go back to the class. I indulge you. So you can now bring up questions. And as we have told you, we are still going to make even the material available to you after the training. So you are going to have, we are not holding back anything to get people equipped. Now, that's for that. The risk assessment, what are we doing in risk assessment? For every machine, I'm sharing my screen right now, so I just do hope that you can see it. So for every machine that you see, there is something we have to do about them, which is called risk assessment. What are we doing in risk assessment? We want to know the hazards that are attached to these machines. What are the hazards attached to them? Every machine is not 100%, safe. There is no machine that is really 100% safe. So there must be something that could actually hurt somebody or the operator. So that is the hazard. So you have to identify the hazard. Hazard is anything that has potentials to cause harm. So you have to identify them. So we call it hazard identifications. So hazard identification is very necessary. Is there any part of the machine that can injure the operator's hand? Maybe it can cause burns or it can cause cuts to the person. You have to identify it. Now, after you identify it, then we talk about what? The control, hazard control. So it is in the hazard control I was explaining the level of control that we can suggest based on the critical situations of the hazards we have identified with machines. And I did mention, 5 of them, which really are presented in a conical form, just for us to see, what you need to prioritize. So when you look at a particular hazard, the question you ask yourself is that if the probability of the hazard, let's say the severity and the probability is actually high, okay, it may be an hazard that can cause the death of the operator. If that hazard is activated, maybe it can cause the death of the person, like electrocution or anything like that. So we can think about elimination method. Elimination means that is it possible for us to eliminate that hazard, that it will not be there at all? Can we really do without it? Can we eliminate it? So if we cannot eliminate that hazard, then we talk about substitution. There are some machines. That's why you see that some factory, some industry, you will go there, the same thing that they are doing, but they are using a different kind of machine to do it. So maybe they can be using an improved machine with an improved technology. Now, why are we substituting? So if that machine is so critical that it can hurt people, we can find another machine that can do the same work. That's what we are talking about. So we can substitute. So if we cannot substitute, can we use engineering control? Engineering control really means that can we separate or isolate? Okay, we have isolation, yes, and that one is isolation. Okay, can we isolate the hazard from the operator or from the from man that may actually interact with it? So can we isolate it? So that also comes like an form of engineering control. When you look at some grinding machine, they can put cover on it. That is isolation. When you look at some machine that can cut, they can put a cover around it. So these are isolation in such a way that the person will not freely interact with the hazardous part of the machine. So we can also use like engineering control, like let us improve on it. Okay, can we improve on it? If it's a radiation that can be coming out, can we make it to be a silver surface so that the radiation will be reduced? The rate of radiation will be reduced and all that. So if we cannot use that, can we use administrative control? Administrative means that we want to put up some policies that can guide people. Like for example, in the lotto system is actually an administrative control, just to ensure that when people are working on the machine, nobody switch on the machines so that there won't be anything electrocution. So it will be like, before you work on the machine, go to the electrical department, take the line clearance. When you take the line clearance, follow them to the breaker, collect the padlock, let them put the tag there. These are administrative control. These are policies that guide people on the machine. Okay, when you want to work on the machine, activate the emergency button. When you are done with your maintenance that you are doing on it, you can release the emergency button. These are administrative control. And then if we cannot do that, can we actually resort to PPE? If eventually we cannot isolate even this hazard, the hazard will be there. Definitely it can burn somebody's hand. The machine can burn somebody's hand. Can they wear glove? Okay, if we are talking about it can affect the person's sight. Can they wear eyeglasses, and all that? Like in the welding now, there's no way you can prevent that hacking coming out from the lead of the welding. Can they wear their face shield so that it will protect their eyes? If the place is noisy, can they wear air muff? Can they wear air plug to reduce the level of noise and all that? So this is what we do in a risk assessment, and then we communicate this even to the workers. We educate them about it. That's risk communications and all that. So we can also, use some what we call signage. We can use some signage. Beware of this place. Put on your helmet before you wear this area. Oh, entrance is not made open to you. If you are not an authorized worker and everything that you see around the working work place, or slow down. This is the minimum speed allowed within the factory and all that. So we can use all these things just to reduce the level of hazards and accidents. I hope we have done a little justice again to that. So, but you still need to go through the class. So thank you very much.
Okay, thank you very much, Mr. James, for the response to those questions. Charles, who are busy? Mr. Charles, you can unmute your mic and ask your question in the next 20 seconds. Can you do that? I can see your hand, Mr. Charles. Okay, so our time is fast spent, actually. So please, I want to appreciate everyone for staying up until now in today's training session. So tomorrow is another day again. Tomorrow will be the conclusive day for this training on industrial machinery maintenance. And like we did say, like Mr. James, I said, please just make effort to go back to the classes and make reference to what has been taught in both classes. So the links to the classes will be dropped on the WhatsApp group again. So please let us share them. If you have not subscribed to our YouTube channel, please endeavor to do so. Subscribe so that you can get updates, prompt updates when we release or when we have live trainings that are coming on board. Engineering training, project management training, safety trainings. We have a whole lot of them on our YouTube page that we put out there that you can easily access. So once again, thank you very much everyone for joining. So please, your feedbacks before we go. Let me take one or two persons. Adedeji Damola, if you can hear me, can you unmute your mic? Let's just get your feedback of today's class. What do you have for us? How was today's class? Adedeji Damola, you can hear me?
Yeah, I can hear you. Good evening, everyone.
Okay. Good evening.
Today's class was so interactive, and I really like the way the tutor really take up the class. It's very interesting. I'm looking forward to a better one. And all I can say is that you really did well concerning this topic, and I give you a thumbs up for that. Thank you so much for your knowledge being passed, and I hope in a better future there will be more to this. Thank you so much, sir.
Okay, thank you very much, Mr. Damola. So lastly, Yakubu Abdullahi. Yakubu Abdullahi, if you can hear my voice, kindly unmute your mic. Just get your feedback of tonight's class. Yakubu Abdullahi.
Okay, good evening, everyone.
Good evening.
Moderator and the presenter. We are really delighted with the presentation, and then the presentation, and they are very, very educative. Actually, I'm almost speechless because as I said yesterday, I really learned a lot, and then still today, I still learn a lot actually. Definitely, we really appreciate the effort with the material, even before the material come to our hand. with the material that we learned. Really rich a lot. Thank you very much with this effort.
Thank you very much. We appreciate your feedbacks. It helps us to do better. And when next we are having classes like this. So we want to appreciate you once again. Those who joined us via YouTube Live, thank you very much for joining us. Raji, I can see you on YouTube Live. So thank you very much, everyone, for joining us tonight. So we meet again tomorrow, same time. The link to tomorrow's class will be dropped on the WhatsApp group. So don't miss it. This is basically good night to each and every one of you. So unmute your microphones, your speakers, and tell me good night as well. Good to me. Good night. Good night.
Good night. Good night. Thank you so much. Thank you, everyone. Good night.
Thank you, everyone. Good night.
Good night. Good night. Good night. You'll see.